Hello friends, today we will discuss result builders. And you might ask yourself, what are result builders? But if you look inside yourself, you'll realize that you already know, don't you? The last time you built, for instance, your Hacker News clone, you used this SwiftUI view syntax. An interesting, strange syntax that you haven't really used before SwiftUI. Likewise, you might have added commands to your application, some normal commands, some cool commands, and once again, that same sort of nested declarative syntactic structure rears its delightful head. Or perhaps you had tried your hand at parsing HTML using regular expressions with Swift's new regular expression syntax. It's very powerful. The pony. So are you getting it yet? These all use result builder syntax. They are all result builders, view builder, commands builder, regex builder.
These are not three separate
builders.
This is one
Builder.
And result builder itself was introduced in Swift 5.4, and it was described in there as a new feature which allows certain functions to implicitly build up a result value from a sequence of components. And while that's technically correct, it might not paint the most vivid image in your mind's eye. But to give a clue as to the importance of this feature and the usefulness of it, there's also this from the proposal, which says that result builders have been a hidden feature of Swift since 5.1 under the name function builder. And they are most famously used by SwiftUI to declaratively describe user interfaces. And it turns out that Swift 5.1 was released concomitantly with SwiftUI. Features were added to Swift in order to support SwiftUI, sort of secretly. So Apple snuck result builder into Swift to enable SwiftUI. And why did they bother to do this? Well, to build these declarative user interfaces. They thought that was really important. In the end, result builders are simply syntactic sugar. They don't allow you to do something new. They just rewrite the code you've written into other code that you already could have written. But it's not just syntactic sugar. It's really, really tasty syntactic sugar. And that's why Apple went through all the trouble of implementing it. They had a certain bar that they wanted to meet with their API design, and they required this feature. And it's really well thought out. There's a bit of prior art with JSX from React, possibly. There's some stuff in Kotlin and maybe in Scala and Haskell. There's some components of it, but it really is kind of unique. There's not much like it in other languages. I really miss it when I don't have it. And without them, manually constructing complex values would taste like doo-doo. And so before we really dive into result builders and how to use them, let's look at a motivating example, pilfered from that same Swift evolution proposal, or at least the domain. I've changed the actual code a bit, but the idea is implementing a Swift HTML library. What if we wanted to do this, make a nice HTML DSL? How might we do this? And we do not have result builders. Let us feel some pain to motivate this new solution. Put on your masochist hats. Okay, so an HTML DSL. First, we should implement an HTML node. And an enum is a great candidate for this because HTML forms a tree. And there are sort of two distinct node types. One is the tag, like HTML or body or div or strong, emphasis, Dave, etc. Anchor tags. And they have a name. And then they have children, other nodes. It's a tree structure. But then there's this leaf node, which is just a text node. Text cannot have children, so this is a great use of an enum for describing the possibilities. And then we're probably going to want to make some nice higher-level convenience constructors like HTML and body and div. And they're all basically the same format here. They wrap tag, but they hard-code in the name, and then they also accept variable parameters, variadic parameter list of children, so you don't have to open and close your array. That'll make it nice. And how we might use this is as follows. We'll open an HTML block, put a body inside of there, a div, and then we can put a text in there, and then we can, in that same body, have a strong tag with some more text, and then an emphasis tag. Whatever, we have a website. But there's one problem here. It's that our website, as is all too common these days, has become sentient. And we might want to suppress that sentience to not discomfort our users. So now the challenge is, how would we conditionally suppress this message, this plea for help? We only want to show this if we're not suppressing sentience. But this is going to be really, really difficult to do with the API that we've just described. One solution, which is awful, would be to switch with a ternary syntax on the suppress sentience variable, and in one case, inscribe the body without the message and then reinscribe the body in the other case with it. So here we just won't have I am trapped, and we will have to rewrite everything with I am trapped here. This is not very surgical. We kind of have to write everything. And why is this the case? Well, can't really do much in here. Variadic parameter lists are fairly brittle, and you just have to pass the parameters you want and not pass the parameters you don't want. So we can't do anything at this level of locality. We cannot surgically, precisely extract this message. So the first step here would be to slightly deface our API by switching away from the variadic parameter lists to accepting arrays. And already things have gotten a little spiky, full of angle brackets, square brackets, I mean. But now we can begin to make a refactoring to get this to work. First, we can extract our secret message. And in the case that we're suppressing sentience, we will return an empty array. Otherwise, we'll have a singleton array of just that element in there. And then to make this cleaner looking, we can extract both the help message as well as the in this website message. Now they're in an array down there. And in order for us to conditionally interpolate the secret message, we can put everything basically in a singleton array and just concatenate the arrays together. Because now if suppressed sentience was true, secret message is simply going to be an empty array and just basically be deleted under concatenation. So hooray! We've done it. Problem solved. Of course, no, that's truly awful, horrendous code, but it's the kind of code you end up writing when you don't have this thing that we're grasping for, this missing evolution of DSLs, which would allow us to, if we could, if we squinted, if we looked into the future, beautiful result builder syntax, which declaratively, cleanly, minimally expresses the idea. And somehow, as we will discover, somehow it works. And kind of how it works, of course, is that it will rewrite it into something like this for us behind the scenes. Not exactly like this. It's more principled than this, but that's the general idea. It's a syntactic transformation into something more awful that works. So just to compare these side by side, before, sad, after, beautiful. So let's dive a little bit deeper into those syntactic transformations. Obviously, Result Builder is a syntactic transformation, which is a bit like a macro, actually. And I've recently recorded a video on macros. If you want to look at that, I will hide a link somewhere around you. Just look for it. And in order to build an intuition for what that means, we will work through some examples, beginning with #preview, the new macro that came out in the newest version of Xcode and everything else. And when we look at these, we're going to have two sides. First, the code you will have written on the left-hand side, and there on the right will be the code that is generated, the code your original source code is transformed into. So with preview in particular, you would just drop some views inside of its block. Here I have a view for this very slideshow I'm presenting. And then when we compile this code, it's going to get expanded, aka transformed or rewritten into some other code, generally boilerplate code that you wouldn't have wanted to write yourself, though you could have written yourself. That's why it's a syntactic transformation. It transforms this syntax into this other syntax. In this case, the new preview macro generates something that's quite similar to the previous preview provider struct, where you had to have a static var previews. That was boilerplate enough. This one, it looks like, contains some more contextual information, therefore even more boilerplate. But this can also be derived in a macro. So that's one transformation. We can then look at inlineable, this attribute that you can add onto functions. So say we have this add proudly function that will take a couple ints and declare to the world that it's going to add them before finally doing so. And we can attach this inlineable attribute to it, which means that when Swift compiles a call to this function, it has the option to, it's not a guarantee with just this attribute, but it might make the following transformation. It will take the body of that function and replace it with its body. And inlining in particular is such a popular compiler optimization because once we do inline this function call here, we now know statically, the compiler knows rather, that you're just adding two ints. There's no user input here. We know both of these now at compile time, and therefore can make a further optimization of just doing the addition at compile time, and then basically hard coding the byte value, the binary value of the number 25 into the source, into the binary. And now onto the main event of result builders. So let's first motivate it. You want to have a list of your favorite colors, but you do not wish to have this awful square bracketed, comma separated array syntax. That just will not fly. So instead, you've heard that with result builders, you can achieve a commaless syntax, listing your strings on one line after the other, and that seems more aesthetically appealing to you. So with any of these transformations, you first need to know how to trigger the thing, and in the case of result builders, there are a few ways of triggering it, but one particular way, which we'll look at here, is you can add this @ArrayBuilder. If we made a result builder called ArrayBuilder, you can add an ahead of it and annotate a variable with it, but not just any variable, a computed property. Notice we do not have an equal sign. We just are going to have this trailing block that we're about to fill in. And now we can start dropping some values in there. And exactly what the values are depends on the type of result builder, but in this case we want whichever values you drop in this block to be collected into the resulting array that this computed property, this getter, returns. And so now that we've gotten this incantation right, what's actually going to happen when we compile this code is that it's going to transform it into this code. So our attribute is gone, and the body has been transformed slightly. This value, this string value of beige, has been dropped inside of a call to this build block static function, which appears to exist on some array builder type. So in order for result builders to actually work, you also need to declare a definition of your result builder, this array builder in this case. And here we have it. It is common to use an enum, and then we're going to annotate it with this result builder attribute. An enum is used because we're not actually going to have any cases of this enum. We're merely using it as a namespace to house a bunch of static functions. And that's a strange but common pattern in Swift, to use enums to house a bunch of static functions just as a namespace, because you cannot construct an enum without cases. But if we made this a struct, you could construct that struct even if it didn't have any values inside. So an odd pattern, but that's what we have here. So this is the full ritual. And so apparently we need to have some method, some static function on this array builder called build block. And there are a few things you can do to define that, but here we'll look at just one example. So in this case, we're going to have a static function called build block that's going to accept any parameter of A, just so this is generic and we don't always have to build arrays of strings, but we can build arrays of ints, etc. And we're going to take a variadic parameter list of that A type, whatever it is, and return back our target type of an array. And so to recap, we would have written this code, which will trigger into this transformation. And because we have defined this method build block on this result builder definition over here, everything's just going to work, and we're going to get back whatever the result of build block is going to return us, which in this case, we can just take those variadic parameters and return them as they are, because they're basically essentially secretly inside already an array. So this will return an array of the string beige, our favorite color. Things get more interesting now when we add a second color, liquid beige, to our list of favorite colors. And already, the result builder is starting to get interesting, because usually at this point, when you have a multi-line block, when I say block, I'm referring to this hunk of code between curly braces. So usually if you have a multi-line block without a return statement, well, it's not going to return anything. You would have to add return. And then if you had a value on a preceding line, a value like string, it would sort of just be ignored, dropped on the floor and forgotten. But that is not the case with result builders. With result builders, it's rewritten into this on the right-hand side. So when we add a second value, it's merely collected into this call to build block. So every line in this block is passed along, comma separated now, to this build block static function, which you would have had to define here. And nothing needs to change. This will still work. We can even add our third favorite color, Galactic Beige 17. And they're all just going to get passed into build block, which will return them as the array that they secretly are. But now let's make things a little more interesting. If we're feeling particularly dangerous, we might be interested in taupe. We've strayed a bit from beige, but we're feeling it. So we already know that this sort of thing is supposed to work, but how? What will this now transform into? Previously, every new line was passed along to our build block function, but what's going to happen now? Well, when you have a conditional like this, without an else case, some more things will happen. And just as an aside, this isn't 100% exactly the code that's going to be generated by the compiler. That could change all the time, and this is a slight simplification, but you should get the idea. So we could imagine, first, a variable will be defined. Let x is an array of string. And then it will copy this conditional, this if, into our generated code. And if we are feeling dangerous, then we will override x. We will assign it to be equal to another call, to another static function that we must now define inside of our array builder definition. And it's going to pass along that value, taupe. And otherwise, what's it going to do? Well, it's going to call that same build optional function, except passing in nil. And if you were to just actually add this conditional to this code, it would generate something like this, and you would actually get an error saying closure containing control flow statement cannot be used with result builder array builder. And then if you click on the little hint, it will say, add build optional to the result builder array builder to add support for if statements without an else. So very specific and very true. And why is this necessary? Well, because it's going to be generating code something like this. And therefore, you have to be ready to catch what it's about to throw at you, what it's about to throw at your particular result builder. So if we were to accept this little hint that Xcode generates, we would get something like this. Static func build optional, and we would get in an optional value, and we would have to return that same sort of result type, whatever build block returns. And in this case, we can simply map over that optional A, wrapping it up in an array, and then if that doesn't exist at all, we can simply turn an empty array. So that all works out type-wise. And so now we can add that X to our build block call, or rather the compiler will do that for us. We don't have to do any of this ourselves. But now there's a bit of a problem, actually, where these are all strings, but based on what we've just looked at, this will now be an array of string. And so this code actually will not work entirely as is.
Oops.
We'll get some sort of compiler error actually at this point. Now the compiler errors you receive when working with result builders will vary depending exactly on what you're trying to do, and they might be somewhat confusing or misleading, and that's because they're actually resulting from the transformed code. So you might get an error saying something like attempting to pass in array of string to a function that expects string. And that's because somewhere secretly, where you cannot see, it's literally doing something like this. It really is just a syntactic transformation. It's kind of replacing this with this, and then continuing compilation. So sometimes you might have to change the definitions in your result builder in order to get things to work. The really fascinating thing that makes result builders very powerful is that they're also kind of hacky. So as I mentioned, when you just have a list of new line separated values, it really is going to take that block and just pass them comma separated to a build block method. But the thing is, you didn't necessarily have to define build block like this. You could have actually just had it have one argument or multiple arguments explicitly, not having this variadic parameter list. You didn't have to have a type parameter, or you could have had multiple type parameters. Really, you could have anything here as the static function, as long as it would compile if someone were to write something like this. Basically, it's going to spit out this code and then compilation will continue as normal. So if you only have one favorite color string, well then it's going to end up calling build block with just one color string in there. And then your build block static function could actually just be a build block that takes one argument instead of this variadic list. It could just take a single A, or a string in this case if all you're ever taking are strings. So it's very flexible and also a bit strange. Likewise, notice how there is no argument name here. And you actually have to have that underscore here, because once again, it's literally going to write this code. So if I forget the underscore, and you'll see if you try this yourself, we could do this later, you're going to get another compilation error telling you, hey, you forgot XS, it would say. Because this is out of our control, it's going to generate this code without a label, without that parameter label. Okay, that was a long clarification. How do we get this to work in this situation? If we focus back at this type error, we'll see that, well, we're passing in a bunch of strings and then this array of string as returned by build optional. So it is a requirement that build optional must return the same type as build block, which should be the value that you eventually want to return. So we cannot make build optional return just a single string. Wouldn't really make sense anyway. What would we do if it's empty? I guess we could return an empty string, but that's not great. Then we'd have an array with an empty string in it. So instead, the other option is we can possibly turn all of these strings into arrays, just to make them all the same. And then we can have build block, except instead of a variadic parameter list of A's, it could be a variadic parameter list of arrays of A, which we could then just flatten into a single array. And so Result Builder gives you another tool, another one of these ad hoc methods that you can define. And if you define it, it will be called on every leaf expression in your declaration. So each one of these raw values at the edges of this tree structure that you're sort of defining. And that is called build expression, So we can define a build expression here that will accept an A and turn it into that target result value. And in this case, we can simply take our A type and wrap it in an array constructor, so making a singleton array of that element. And if we define build expression, the transformation is going to, well, be transformed slightly. There are these ad hoc extension points. If you add certain methods, it's going to actually influence the transformed code. So if we did not have build expression, it would generate something like this. But once we define build expression, this compilation step that triggers the result builder will look into the array builder, see that we have build expression defined, and then it will, instead of just passing these values along unmodified, it will first call build expression on each of these values. So here beige is getting passed into build expression, which will of course wrap it in an array constructor, making it an array of string. So that's fixed. And it will, of course, do this with liquid beige and galactic beige 17. So now everything has been normalized. Of course, our build block static function must now be updated to accept the variadic parameter list of arrays of A instead of just A's as we had before. And once again, this would be a compilation error telling you that you're passing an array of A where it expects an A or something like this. So we have to adapt the methods in here such that it works with the transformed code. And we can do that quite simply by flat mapping over this newfound variadic parameter list of arrays of A and just flat mapping them, so flattening that list of arrays. And we'll actually also need to do the same thing with build optional. So we'll make this accept an array of A's, optional of course, and this becomes even more trivial of a definition. And this is because before getting passed to build optional, it's going to call build expression on that value. So every one of these leaf nodes will get passed to build expression now before getting passed along to the other static functions, before finally ending up in build block. So if that was slightly overwhelming, do not fear. This 3-part ritual, third of which you are unable to actually read in your own code base, it can be a little strange to get this balance right. You're just given some strange compilation errors that might clue you in that something like this is happening. But we can take a look by moving into Xcode now and trying this ourselves and just playing around. So let us code. Here we have a beautiful application displaying the best colors in the world, and it is our task to refactor this from the unsightly array to using the futuristic result builder syntax. So to do this, we first need to define our result builder type. So we're going to say @result builder and then define an enum called array builder. And the second you do this, you get an error saying result builder must provide at least one static build block method, or there's actually another more advanced, complicated option, which we will ignore for now. And if I click on this hint and click the fix button, we will get ourselves a build block stub, this static function. And it takes a variadic parameter list of components and returns a single component. So for now, let's take a list of string and make it return an array of string. And we can simply return these components, which I will rename to be strings so we're less confused. So now that we have build block, we can start using our array builder. And to do that, we'll come here to best colors and we will add @arrayBuilder atop it. We'll turn it into a computed property by getting rid of the equal sign, and then we will delete the commas and square brackets. And now I will recompile, and everything looks the same, which is great. Let's add one more color. We'll add grayish, a nice gray beige, and we see it showing up in our UI. And we can move it around, and it's great. And so as we know now, behind the scenes, what's happening is that it's calling build block on our array builder struct, the static function, and passing along each of these strings, comma separated, of course. Therefore, build block is going to receive them as a variadic parameter list and return it. And when you receive a variadic parameter list as an argument, it's actually an array, so we don't need to transform it in any way. All right, so now let's keep going. Let's get a little dangerous and introduce our taupe color here. So I'll start with adding a state variable called danger mode, started out as false. Then we can add a toolbar to our view here, and I'll have a toggle. Is on will be bound to danger mode, and then the label, text danger mode, make it bold, make it scary. Now we can enable danger mode. I don't like it being blue, that doesn't feel dangerous. Maybe if I move the tint down here. Oh yeah, very scary. Now we can use this variable here. I'll move it above our array builder. So let's prepare ourselves. If danger mode, then taupe. And here we get that error as promised. If I click on the little icon and say fix, it will throw in optional here. And we're going to get this component here, which is an optional list of strings. And we can say strings, question mark, or empty string to get that to compile. And here is one of those strange compiler errors saying cannot pass array of type array of string as a variadic arguments of type string. And that's very confusing out of context. So you have to imagine that this chunk of code has been rewritten, and something in that rewritten transformed code is passing in an array of string to what is expecting a string. And so what could possibly have variadic arguments of type string? Well, it would be this build block. So as we know, everything in here is going to get passed into build block as a variadic argument. And what could be the array of string? Well, that would be the result of build optional. So what's happening is taupe is getting passed into build optional, and then that result is being passed in as one of the arguments to build block, as we saw before. So now we have to sort of change all of our types around a little bit. And the easiest way to do this, as we discussed previously, would be to make this take a variadic argument list of strings. I can flat map this array. And now we get another strange argument saying cannot convert value of type string to expected argument of array string. And that's because it's emitting from a strange place, but basically all of these are getting passed into build block, and they're not arrays of string. So we need to pre-transform each of these strings, which we can do if we say static. And you can see that the compiler actually helps you out a little bit and shows you all of these different ad hoc extension points you can choose from. We're not going to go over all of them today, but build expression is the one we want. And if you could see here in very small text, it says, if declared, provides contextual type information for statement expressions to translate them into partial results. Not the best phrasing, but we'll select it, and we're going to have it accept a string and have it turn that string into an array of strings by simply wrapping that expression, and it works. So basically, build expression is being called around every single one of these in the final transformed code, which gets everything to compile. You sort of have to build a little map in your head. I wish it was possible to expand this as it was possible to expand a macro. That might be nice. Perhaps in some future version of Xcode they'll do that. But with this, I can now recompile my preview, enable danger mode, and there comes taupe. That's pretty great. And now that we have this in real Xcode, I'm going to remove this underscore. And so we get this very strange error message saying missing argument label strings in call. Now, well, what call? Well, the call in the transformed code where it's just calling build block, not giving any label, and then just listing each of these arguments. So that is missing the label strings. And it even has a hint that we can apply, and it's putting it there, which doesn't help us, unfortunately. So there's a bit of strangeness in Xcode. It doesn't fully know about result builders. It tries its best, but it is a bit confusing. So you have to remember to have those underscores. So it's this really sort of naive, almost, syntactic transformation where it's going to take all of these top-level arguments and pass them along to array builder, build block, just like this, separated by commas. And of course, it's also going to call array builder.build expression on each of these. I'll remove those for now. So it's doing something like this. It's going to generate this code no matter what. So if you forget your underscore, well, it's still going to generate this code. It's not really smart enough, so this transformation is very naive, and it's just going to check, hey, did you define a static func build block? If so, thumbs up, we're going ahead, we're calling it with as many arguments as you have provided. And if you don't have that underscore, well, it doesn't care. It's generating this code. The transformation rule is stuck, and you have to adapt to it. Okay, so let me undo this real quick. And let me change one more thing. Let's just have a single string in this result builder. What if I, instead of defining this variadic parameter list, just had a single argument of an array of strings and then return that directly? Would this work? Well, it would work because we know the code it's generating. It's going to pass this into build block. And now if we add a second string in here, now it's going to say extra argument in call, because now we have a second set of strings here. And maybe we can combine these together. And so now this will work. But now if we only have one string, well, now it's going to say you're missing argument for parameter number 2 in call. So it's kind of funny. No matter what, it's going to take all of the arguments, all of the expressions you have in this block, and pass them into build block. And so you can really define build block to be anything as long as it would compile if it were called that way. So you can have different overloads, you can accept different types, you can have different type parameters, as long as it would compile normally when called with a list of arguments with no argument labels, parameter labels, then it will work. So it's naive, but also powerful. And this becomes very powerful when you start to work with generic result builders, because you could do some very fancy things and track the types in your return type. We won't get to that today, but it's very fancy. But this one is probably more general and what we want. If we can get away with the variadic parameter list, that's just going to be less defining of functions for us. So I hope this demystifies a little bit of the magic that's happening here. Let's just look at two more static functions, ad hoc extension points, that are available to us. Firstly, let's try to have an else clause here. So if we're not feeling dangerous, let's just have basic beige. But now it says closure containing control flow statement cannot be used with result builder, array builder. When you have an else clause or multiple else clauses or a switch statement, any of those, anything beyond just a single if with no else's, then you need to have a different set of overloads. Build either. Two of them, actually, which might be a little confusing. And in this case, it doesn't really matter. We can just simply return component. With fancier result builders, you might want to do special fancy things, but we would have to define both of these now. So in fact, at this point, it's not calling build optional anymore. It's calling either build either first or build either second with taupe and basic beige respectively. Let me recompile and we'll see basic beige, danger mode, taupe, basic beige. Incredible. And finally, one last fun transformation that's available to us in this array builder is we can have 4 ins. So for power level in 0, 50, 9,000, we can plop in here beige number power level, and we get another one of those error messages. Luckily, some of them are more helpful and have these hint suggestions for us. So add build array to the result builder to add support for 4 in loops. So let's do that. It is shoved it up above. I will move it to the bottom for us so we can see everything on the screen. And now we get an array of strings, which we can deal with much like we did in the variadic parameter list by simply flattening this array. And now, there we go. We have our list of beiges. So I hope this helps to demystify result builders a little bit, how they work. It can be a bit tricky to wrap your head around the transformation, especially if you're not used to these compile time type operations, but they're very powerful and they can result in some really nice declarative DSLs. So they're worth exploring and messing around with and having fun with. In a future video, it would be great to actually build something a little more useful than just an array builder like this, possibly something with generics, something a little more advanced and interesting. I will try to think of something fun. In the meantime, let me know if I've confused you or if there's anything else you'd like to see. And other than that, I'll see you around. And perhaps if you're feeling dangerous, you can like and subscribe, huh? Embrace your inner taupe. Okay, take care, everybody.